Okay, so we've got the 2017 BC International Exam. This is question number 1. This is calculator active. And I really want to make the most of our graphing calculator here. We're going to be really careful with the work here. We're told that for the time interval 0 less than or equal to t less than or equal to 8, a particle moving in the xy plane has position vector given by x of t and y of t is sine of 2t comma t squared minus t, where x of t and y of t are measured in meters and t is measured in seconds. So my position in the x is given by sine of 2t. My position in the y is given by t squared minus t. And they want me to find the speed of the particle at time t equals 2. Well, when we're dealing with parametrics, the speed at any time is found by looking at the velocity in the x direction squared plus the velocity in the y direction squared, and then you evaluate at whatever particular time we need. In this case, it's going to be at time t equals 2. All right? Now, I could pretty easily find the derivative of sine of 2t and find the derivative of t squared minus t, plug it in, but what I want to do is I want to see if we can maximize our calculator here for this work. So previously, I graphed the x-coordinate sine of 2x as f1 and the y-coordinate x squared minus x as f2. And what I want to do is take that expression we just saw, which involved the square root. We need the derivative, and I want to be careful about this. We need the derivative, so I'm going to go to Menu, Calculus, Numerical Derivative, at x equals 2 of the first function, and I need that squared, plus I also need to square the derivative of the y at 2. That's going to be f2 of x. Make sure I'm doing this correctly. I need the derivative of the x-coordinate evaluated at x equals 2 squared plus the derivative of the y-coordinate at 2 squared. And let's see, we're going to go on over, and the value is 3.272. That matches the College Board, so excellent. So the value is approximately 3.272. They awarded 1 point for this initial expression, 1 point for the 3.272. So we've picked up 2 points, and the calculator really has done the majority of the work here. All right, let's move on to part B. All right, so part B, the question says at time t equals 4 seconds, is the speed of the particle increasing or decreasing? Explain the answer. Now in calculus AB, if we're talking about speed increasing or decreasing, normally what you would do is you would look at the sign of the velocity and you would look at the sign of the acceleration, and if those have the same sign, they're both positive, then your speed is increasing. And if the signs are different, one's positive, one's negative, the speed is decreasing. In parametric mode, though, we actually have a formula. We know that speed is the derivative of the x squared plus the derivative of the y squared. What we can do is we can take this information, and what we're going to do is we're going to say, okay, let me actually find the derivative of this speed expression at t equals 4 and see what happens. Now, here's where things are going to get tricky. What I really want is speed prime at t equals 4, which is going to involve taking a derivative of the square root of this expression here at t equals 4 And quite honestly, that might be a little too much to type into the calculator. So what I want to do is, let's see what we can do. I need the derivative of the square root. I need the derivative of the x coordinate. Well, the derivative of the x coordinate is going to be the cosine of 2t times 2. I need to square that. Plus, I need to take the derivative of the y, which is 2t minus 1, and square that. I'm going to type all the stuff that's in the radical into the calculator as my function. I'm going to find the derivative, and I'm going to evaluate the derivative at t equals 4. So let's go back to the calculator. And here we go. We need to find a derivative at 4. Now, what specifically are we taking the derivative of? We're taking the derivative of the square root, and what I had was 2 times the cosine of 2t, or in this case 2x squared, plus 2t minus 1 squared. I'm taking the derivative of everything that's in the square root, and I'm evaluating it at x equals 4. Uh-oh, variable's not defined. I made a little mistake somewhere. Oh, do you see it? Right there. It's not 2t minus 1. Shameful, Mr. DeRosier. It's 2x. So I'm going to highlight that, hit enter. That's the copy paste feature. Change this to 2x minus 1 and hit enter, and that is approximately 2.163. Well, what does that mean? I know that that is positive, so I'd say something like, since speed prime at 4 is positive, the speed is increasing at time t equals 4. So they awarded 1 point for considers s prime of 4. So I'm not really sure what they're going to consider s prime. That could be that you've done this setup and you're like ready to take the derivative. And then they offered another point for coming up with your reason with justification. Well, that's going to be a grand total of 2 points. All right, let's keep going. Okay. Part C says find the total distance traveled by the particle over the time interval 0 to 5 seconds. Total distance traveled. This is another one of those concepts that we study in Calculus AB that changes a little bit when we move into parametric mode. To find total distance traveled, you're going to integrate from 0 to 5 your speed expression. So it's the square root of dx dt squared plus dy dt squared. Integrate that with respect to t. All right, so let's do it. And you can do this a whole lot of different ways. So let's go to menu. I'm going to go to calculus, numerical integral. We're going to integrate from 0 to 5. We are integrating the square root of the derivative of the x-coordinate squared. So that was 2 times cosine 2x. I want to be careful with my parentheses. That's where the square goes. Whoa, Nelly. Squared plus the derivative of the y-coordinate squared. Integrate that with respect to x. And I'm getting 22.382, which agrees with the rubric. So this integral expression has a value of 22.382, And if you want to include units, feel free. The units are going to be meters. College Board is awarding 1 point for knowing the total distance traveled expression and 1 point for coming up with the correct numerical value for a grand total of 2 points. Not too bad. All right, part D. Let's land the plane here. At time t equals 8 seconds, the particle begins moving in a straight line. For t greater than or equal to 8, the particle travels with the same velocity that it had at time t equals 8 seconds. Find the position of the particle at time t equals 10 seconds. Okie dokie. So let's see what's going on here. At time t equals 8 seconds, the particle begins moving in a straight line. For t greater than or equal to 8, the particle travels with the same velocity that it had at time t equals 8 seconds. Find the position of the particle at time t equals 10. That means I need to know the position, the x-coordinate of the position at time 10, and the y-coordinate of the position at time 10. Okay, well, what's going to make this a little bit tricky is we need to figure out what was the position at time t equals 8. Let's see, well, what do we know? They gave us the velocity, they gave us this position expression, sine of 2t, comma, t squared minus t, and we were told that that worked on the time interval 0 to 8. So the position at time 10 is the position at time 8 plus however fast or slow the position in the x-coordinate was changing. Well, we're told in the problem that the particle travels with the same velocity that it had at time t equals 8. So whatever your derivative is for the position at time 8, you're going to integrate that from 8 to 10. You can follow the exact same work for the position in the y-coordinate. It's the position at time 8 plus the integral from 8 to 10 of y prime of 8 dt. And let's go to the calculator and see what we can do with this. Let's keep in mind that I typed in the position function for the x as f1. So I want f1 of 8 plus I want the integral from 8 to 10. Now, I want to be careful. I want the integral of the derivative at time 8 of f1 of x, and I want to integrate this with respect to x. And that's going to give me negative 4.119. I'm going to repeat this process for the y-coordinate. So that's f2 of 8 plus menu calculus numerical integral from 8 to 10 of your derivative at time 8 of the y-coordinate, and integrate that with respect to x. And that gives me 86. So let's go back to the notes here. Okay, and I would want to say something like the position of the particle at time t equals 10 is, give it to me as a point, negative 4.119 comma 86. All right, so what did they say? They awarded a point for using the position at t equals 8. So I'm assuming they mean both the horizontal and the vertical position. Using both of those gets you a point. 1 point for using the velocity at time t equals 8. So that's velocity in the x and velocity in the y. And then 1 point for actually determining the position. So that is your total of 3 points. I can think of at least one or two other ways that you might want to approach a problem like this, but essentially it's all going to be the same. The position at time 10 is the position at time 8 plus the total change. Something that you could have done differently is that because you're told that the particle moves in a straight line with the same velocity, you could just say, well, if I know the velocity in the x direction, that has some numerical value, and I'm traveling in that direction for 2 seconds, rather than integrating from 8 to 10, you could have said, what's this numerical value? Let me multiply that by 2 and add it on to the position at time 8. Do the same thing down here with the velocity in the y direction at time t equals 8. It all works out to be exactly the same thing. All right, that's it.